Okay, we'll begin with a picture of our unit circle, back to the unit circle, and we're going to begin by labeling our axes in degrees. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and by the time we've come all the way around, we're back to the starting point, which we can also label as 360 degrees. We can count continuously. Well, what we're going to do is we're going to change our unit of measure. And that's all we're doing, is changing unit of measure. If your home is located 2 miles away from school, well, if you change miles to kilometers instead, the number is going to change. I'm not quite sure what the conversion is. Okay, well, I just looked it up. It's about 3.2 kilometers. Just because you've changed your units doesn't mean that your house has physically moved closer or further away from school. All we've done is a unit change. Well, that's what we're going to do today. We're going to take those degrees that we've been measuring circles in forever, and we're going to change the units on them. So instead of measuring in degrees, we're going to measure in something called radians. And I'll mark off where the radians are. In radians, this is still the 0 point over here, so this is 0. And oftentimes you won't see any numbers associated with the radians. Every now and then you might see a little R down here. But if you don't see a number, we'll assume it's radians. That means if you're not putting those little circles after your degree numbers, I could assume the radians and could mark those wrong. So get in the habit of putting the degrees after your degree measures. This is 0. Well, on the no slide, you saw that going full circle means we've gone 2 pi. So just like we can have 0 degrees and 360 degrees, 2 different names for the same location, we have 2 different radian names for that location, 0 and 2 pi. And if we went around again, it'd be 4 pi, and around again, it'd be 6 pi. Well, if it's 2 pi going all the way around the circle, that means if we've only gone halfway around the circle, we must be at pi. And halfway in between 0 and pi is half of pi, or pi over 2. Halfway in between pi and 2 pi is 1.5 pi, but we don't use fractions like that. We'll call that 3 pi over 2. And so now you see the location around the circle. So that's what we're going to do. If we have an angle in standard position that shows up in quadrant 2, well, it's somewhere in between 90 and 180 degrees. It's also somewhere in between pi over 2 and pi. And so we're going to use this information to go back and forth. We have a little formula that was on the no screen. Degrees over radians equals 180 over pi. You can plug in what you have and solve for what you don't have. We're going from degrees to radians. So I have 135 degrees. I don't know what radians are. On the other side, it's 180 degrees on top, and on the bottom, it's pi. Make sure that your degrees are both on top, and it would work the same way if you flipped it over, as long as your degrees were both on the bottom. In order to solve this, we'll just cross multiply. 135 pi is equal to x times 180. Simply dividing both sides by 180 will get you a new fraction, and that's in radian measure. You just have to make sure that that fraction is a reduced fraction. So let's grab the calculator and let the calculator tell us if it's reduced or not. 135, fraction template, 135 on top, a 180 on the bottom, and this ought to reduce. It does, reduces to 3 over 4. So we'll write that. We're actually reducing these numbers here. I still have a 3 on top, I have a 4 on the bottom, I still have a pi on top, so my answer in this case would be 3 pi over 4. So 135 degrees is the equivalent of 3 pi over 4 radians. We'll do one more of these. Look at the 240. I'm going to again use that formula. 240 degrees on top. I don't know what the radian measure is, but I know it's equal to 180 degrees over pi radians. And this formula works because 180 and pi are in the exact same location on the circle. Let's cross multiply. You're going to get x times 180 is equal to 240 pi. We'll divide both sides by 180, and we'll have to use our calculator to clean up that fraction. 240 over 180, not that you have to. If you can do it in your head, you're welcome to. 240 divided by 180, and that's going to give me a 4 over 3. So I'll rewrite my answer as 4 pi over 3. We're not dividing out that pi, so make sure it shows up in your answer. Okay, if we can go from degrees to radians, we can go from radians to degrees. I'll do the first one using my formula. Now just sit back and watch this. Don't take notes on this because I'm going to tell you an easier way in just a minute. I want you to see that you can use this formula if necessary. I don't have degrees. I'm going to make that x, but I do have radians. My radians is 3 pi over 2. And that's all equal to 180 over pi. It's time to cross multiply. X times pi is equal to 180 times 3 pi over 2. I'm going to end up dividing both sides by pi, which means I can put the pi down here in this fraction. This cancels out, x equals, and now the pi on top cancels with the pi on the bottom. We could pick up our calculator to reduce this. Should give me 270. And that's 270 degrees. So I can always use this formula. But if you're going from radians to degrees and you already see pi inside of your radian measure, you can just replace pi with 180 and then reduce that fraction. And so I'm going to grab my calculator and use a fraction template on this one. On top I've got 11 times 180. Go down the bottom and put a 6 down there. I hit the enter key and I get 330. So this becomes 330 degrees. And so you do have to show that you replace the pi with 180 and make sure that you have used your calculator to come up with a degree measure for that. And those degree measures really shouldn't be left in fractions. We can use the formula on that as well, but you really don't need to, but you can prove to yourself that it does work. Let's move on to the last issue here. In the case of the last problem, I've got a radian measure of 1. So that's not going to be easy to just replace the pi with a 180. I won't be able to do that. I'm going to be forced to use the formula on this one. So I don't know what my degrees are, but I do know what my radians are. On the other side of the proportion, I've got 180 degrees over pi. So x times pi is equal to 180. We'll divide both sides by pi. And so my answer is x is equal to 180 over pi. Now I know that doesn't sound like a degree measure, but we did convert from radians here 2 degrees. So this number 180 over pi is actually in degrees, and it tends to be irrational. Okay, going from converting back and forth, let's look at the other formula that you were asked to memorize on the nose screen. Theta equals S over R, and let's talk about what each of the pieces are. If you read the words, and you will need to read the words, you could get a word problem for these. Theta is the radian measure of a central angle, so we'll highlight that central angle right in here, that intercepts an arc length S. When we talk about the arc length S, we're talking about this arc right in here and its length. Now it's not a straight line, it's an arc. It's got curvature to it, so you can't just measure from the point there. You can't use a distance formula on it. In a circle with a radius of length R. So R is actually the radius that's located right here. And when you have this set up, the relationship between the pink arc, the green radius, and the yellow angle theta is defined by this formula here, right here. But it's important to know that you cannot use this formula unless you have a radian measure for theta. It won't work otherwise. So this tells us we have theta in radian measure. Theta is equal to 4.5 radians. So I'll say 4.5 is equal to S is 9, so I can put 9 in place of S, and we don't know what R is, so we'll leave that the variable. And these are very simple to solve as a proportion if you just put the theta side over 1 and cross multiply. It gives me 4.5 R is equal to 9. I'm going to divide both sides by 4.5 and gives me R is equal to 2. So we just found the length of the radius R, we just found the length of the radius R. Now we don't know what units are on S. If S were in inches, then we would have been finding R in inches. If S were in centimeters, we would have been finding R in centimeters. So your units will match the S and R units. In this case, I could give you any two and ask you to solve for the third unknown. Okay, last type of problem that we might want to be able to do here is given an angle in radian measure. Well, let's convert it to degrees first. 10 pi over 9. This is one of those simple, since you see pi in it, you can just replace pi with 180. You don't really have to use the formula. And then I'm going to reduce. That's going to be, I think that's 200 degrees if I did the arithmetic correctly there. 90, 20, 10, looks like 200 degrees. Okay, so now, oops, got a typo there. Now I've got 200 degrees. And now it says find the reference angle in radians. Well, to find the reference angle, let's sketch it out. 200 degrees would wind up in the third quadrant. The x-axis is 180. This is 200. Remember, theta is right in here. And this is what a lot of you need to get really good at, is drawing and labeling these sketches properly. The only thing you need on these sketches, draw your axes, put your original angle in its proper quadrant and label it, and then label your x-axis. If you're on this side, you're going to be labeling your x-axis 180. If you're over here, you'll be labeling your x-axis 360. And theta is always going to be that angle that's touching the x-axis. We will never be putting a theta out here. We'll never be putting thetas touching the y-axis. Always just the x-axis. So we can now find the reference angle. The reference angle will be a 20-degree angle, because that's the difference between the 200 and the 180. But it says find the reference angle in radians. So since we found the reference angle in degrees, now we've got to convert it back to radians. So we'll say degrees, 20 degrees, over an unknown quantity of radians is equal to 180 degrees over pi radians. We'll do our cross multiply. 180x is equal to 20 pi. We're going to divide both sides by 180. And we'll reduce this. Looks like it's going to be 20 out of here and 20 out of here. We'll leave 9. So my answer is going to be pi over 9 radians. So that's the reference angle in radians. It's a 20-degree reference angle. That means that the reference angle is equal to pi over 9. And then it says sketch the angle. We already did sketch the reference angle, so we've got them in there.